All right, this is properties of integrals. All right, definite integrals at that. So, first integral. If we're going from a to b of f of x dx, that is the same thing as the negative. Some things don't translate well over video. All right, it's the negative of b to a, yeah, of f of x dx. So what happened there?
All you did was put a negative sign in front of it.
I switched the order of the alphabet, which happens to do with numbers. Yes, we changed alphabets in here. Okay. We typically think about this number right here as being the lower limit of integration, and this one as being the upper, or lower bound and upper bound, however you want to think about it. But what happens if this number is here and this number is here? Well, you can switch it around and just make it negative, and it works. All right. Now, this next property is going to play in line with the first one. No? I mean, it may, but I'll have to look it up.
His name is Ecclesiastes.
The negation property.
The negation property of integration. I like that. Okay. Now, one thing, I'm sorry, I needed to make this statement. All of these, we're assuming that f is differentiable on the integral of a to b. Now, in this one, we're going to assume, or this property works if it's differentiable over the interval with an interval that contains a, b, and c. So I have the integral from a to b is equal to the integral from a to c of f plus the integral from c to b of f. Now, one thing that's not said here that can't be assumed. I never said that c was a number between a and b. I did not. C does not necessarily have to be a number between a and b. Think about this in terms of area. I'm saying that the area from a to b is equal to the area from a to c plus the area from c to b. But at the same time, I'm not saying that c has to be between a and b. Not necessarily. Let's look at an example real quick. All right. Now, because the camera shows up better here than it does on the board, I'm going to have to do this here. All right. Here's A, here's C, and here's B. And I'm going to draw some graph, and I'm just going to let that be the shape of the graph. That graph is continuous differentiable over the integral that can, or the interval, I should say, that contains A, B, and C. Now, if I do this right here, and shade in this region here, and shade in this region here, it should make sense that the area from A to B equals the area from A to C plus the area from C to B. I said it doesn't necessarily, but I just want you to see that first. Wait, just a second. I'll get to it. So, this is a situation where A is less than or equal to C, which is less than or equal to B. Are we okay with this?
Yeah.
All right. Now, changing it up just a little bit. I'm going to show you that this still holds true.
You want to put money on it?
You trying to get me fired?
Well. JK.
Don't ask. You never said no. Okay. All right.
I guess I wouldn't be student every day.
He would have lost that. All right. Now, what this is saying here. All right. Would you agree that the area from A to B would equal to this entire area with what? Minus this area. All right, y'all watch what I said just a second. This entire area, or I'm sorry, this area here would equal to the entire area minus this area. Yes.
If you had both of those, why would you do that?
Just watch, just watch. I'm just illustrating a property right now.
Okay.
All right, now let's go back to this, what this is saying right here. All right, the area from A to B, that is still this shaded region right here. All right, but now this time, what is my area from A to C?
It's bigger. The whole thing.
It's the entire thing, right? Now, what's my area from C to B?
It's B to C.
Go ahead. Okay. Yeah, which number did I put up at the bottom here? I put C, but C is greater than B. So what I can do here is I can rewrite this as the integral. I can take this integral that used to be from C to B of f of x dx, and I can rewrite that based on this principle right here. I can rewrite that as the negative of
B to C.
b to c of f of x dx. So now what am I saying when I rewrite it like that? I'm saying that my area from A to B of f of x dx would equal to the area of A to C of f of x dx minus this little portion right here, which is what we said earlier, right? So see, doesn't that make sense? Doesn't that work? And all we had to use was that the negation property.
Correct property.
Okay. So that's good stuff.